Um, okay, so first a little introduction. So as you know, my name is Zaid, and I'm working as a technical architect in Tool Ideas, which is basically a firm based in Italy, and I'm currently based in Dubai. Moving forward, agenda today would be reliable solutions. So we have divided the reliable solution into three aspects: availability, performance, and scalability. And we are going to go deep dive into that. So first of all, we need to set level on what are basically reliable solutions and what are unreliable solutions, what are reliable characteristics and what are unreliable characteristics. So reliable solution is something on which you can depend on, and unreliable is something which is error prone or it is not there when it is expected. Reliable architectures perform consistently, which is also very important because user will be using it day in, day out. And as I said, system that is not error prone and is not, timing out or throwing some errors when users are trying to access it. Unreliable solution is where any solution that takes too long to do any task. It can be because of multiple reasons. And we are going to go into those details as well as why we are going to those processing and timeouts and all those type of issues. So basically, user is unable to do any solution where user is unable to do what he wants to do, and it's blocking it for any reason that can be counted as an unreliable or untrusted solution. So one of the most important thing about reliability is that people usually have this perception that they have built a solution with certain standard that it will be reliable. But reliable is not a constant state. A solution can be reliable today, but it can become unreliable tomorrow because of scale and performance and things like that. Similarly, this can lead to costly maintenance, which otherwise user can spend that amount in a lot of other new technologies rather than spending time and efforts in scaling that solution or making it reliable. So one example that I have from my own experience is when we were working for a insurance firm, and they were like every 6 months they will do a revamp of the system because the architecture with which they started wasn't scalable enough. So their limits are reaching, users are leading, API limits are reaching, things like that. So a lot of energy and time goes into that, and we need to avoid that. So what are the three key habits or key points that can make a solution reliable? We have broken them into availability, performance, and scalability. So we'll look into all of these and how we can optimize these as well. So availability is mostly measure of how much time a system is available for the user and how much time whenever for example whenever a system is not available for the user, it creates an impression that this is unreliable solution. So take an example of any social media website, anything. If it is not available for you even for 2 minutes, it will lose a lot of users. Similarly, if someone is logging in as a service agent, people are calling him, and if it is not available for even seconds, then that solution is not reliable. And there are two levels in it: infrastructure level and the solution level. The infrastructure level is that server is always available. So Salesforce, maintains that. So there are different servers in all their different regions, and Salesforce maintains them to remain available. So we need to make sure the solution remains available. That is our responsibility. The second point is that architect must prepare for downtime. This is very important because we cannot create a system which is 100% perfect, but we need to make it a way where we, declare it and, mitigate it in time and with a strategy. So as Salesforce has a downtime as well when they are doing maintenance and anything, we declare it. So we should follow the same practice as well. So in order to avoid any loss of business value. So the next point is very, very critical. This is, for availability, how can you maximize availability? You need to think it during the design phase. That you need to keep some time for availability to make sure that the system is available when you are designing things, so that you don't have to rework a lot of things at once. Second point is that it is really difficult as an architect as well to convince business users or the business stakeholder to give that particular time and design for availability. But this is a responsibility of architect to talk in the language that they understand to make sure that those areas are worked on initially rather than worked on when there's an issue or anything. How can we improve availability? There are two key factors to it: risk management and failure mitigation. So, what are those? What are risk management? How can we improve it? So, risk management is basically anything that can cause an hazard of potential to break the system. We need to make sure that we have a strategy for that. So it is not something where we are making ad hoc decisions, but we need to plan for it as well. So as an architect, it's your responsibility to make sure any risk analysis represent concern, technical and stakeholders are on board on that. The biggest pitfall, again, occurs when there is no time kept for risk management initially in the project. Okay, the second thing is, how are you going to assess that risk? So, in order to assess that risk, a lot of enterprise companies, what they do, they already maintain their risk management matrices. So, they already have a strategy on what a risk is, how can you identify it, what is the impact on it, and how you're going to mitigate it. We are going to look into one of those scenarios later in the slides as well. Yeah, the second thing is, if you, if availability is down of your solution for any reason, it can create a customer can have a perception that this is not a very good solution. And sometimes, perception is more powerful than what it is. So you need to make sure that it is, available. In terms of business, any risk, any issue that reaches the customer is most critical. It will be highlighted and it will be impacted. So anything that reaches the customer, we need to sort that. So number one thing, prioritize your risk. So ideally, when you see, you should be able to triage them, check them that this is the level 1, this is users not able to access the portal, so the payments will be delayed. Or if they have an experience portal where I worked on, so users used to get medicines for that, for prescribed medicines. So if they cannot log into portal, they will not be able to, get that. So always prioritize your risk. What is more important? For internal users, we can resolve it, but for customers, we need to make sure as soon as possible. We need to have a solid mitigation plan and deliver value early, and iterative approach is important. This is what Salesforce advocates. And once again, if yeah. Okay. So, the next thing is, if everything is important, nothing is important. That is why priority is so important, that we need to make sure that we are prioritizing with respecting that, so that nothing is, P1 or P3, things like that. And Salesforce use V2MOM to prioritize work, which is basically a vision, visibility, I think, measured, operation, and obstacles, and like how. So vision is what is your vision, and like measure what measure you are trying to take, and then what obstacle are you trying to cross, and how do you know, how would you know that you have reached that destination. So Salesforce has created a V2MOM framework, and it is really good. If you want to start from something, you can take a look at it as well. Hello. Okay. The second part is failure mitigation. So any point, any place in the system that can cause significant part of your system to underperform or to not perform at all will be considered as failure. We cannot plan for that there will never be a failure, but we need to make sure that there's a plan for it. Any good system can run into failure point. Good mitigation plan isn't about attempting to pinpoint, but potential failures, we can identify those, or we can predict those, and we need to make sure that we are mitigating them instead. And priority again on failure mitigation as well. So to develop better failure mitigation strategies, we have divided it into three basically types of classification. The first one is people, the second is process, and the third is technology. So for people, there will be a policy. For process, there will be playbooks, continuity plan, and for technology, there will be redundancy. So you can have failure at any points in the mentioned here, which we have categorized. And how are we going to mitigate them, or what strategy should we use? So I've given one example here. So identify that. So imagine if there is a user who is leaving a company. So so that's a triggering point. If you don't have a strategy for that, SLA and requirement, the mitigation will be to have an SLA for that, and to have a mitigation strategy. So how you are going to take care of that. So the basic level is just to have a manual policy where you can someone can perform the SLAs, and you can make sure that those checklists are getting done. Intermediate level is you have a scheduled job which on every week, every month, and any user who is not working anymore, he will get inactive, or if it's inactive user will get deleted from the system, things like that. But a mature strategy will be to have them automated, where their access control is eliminated through the SSO, so they don't have access to log into any system as soon as they are not there. So that was the example. I think it makes it very clear. I've also added some patterns and anti-patterns on availability. So for risk management, we have established risk assessment strategy in use. So there should be a framework. Whatever you decide is best for your system. Risks are categorized into people, process, and technology. Anything and are characterized by people, process, and technology again, and the controls are put in place immediately over time. So in failure mitigation, we need to make sure as early as possible, and as early we identify it, mitigate it, and recover it. Anti-patterns are where there's no classifications and there's no controls, so you cannot if something failed, we are kept with nothing. The second part of this is performance. So any system that is reliable needs to have a good performance. So a performance is basically evaluated as a time taken by the system to perform any task. It should not take like the time it takes to perform some task is called latency. So how fast the system is, how is it performing, in higher latencies, lower throughputs, and You can improve your performance of your system through optimizing the throughput and optimizing latency. These are the two key factors in performance. So think of it as any social media app. Again, if the video is taking too long to load, no one's going to stay on that website again. Similarly, if someone is calling to a service agent and he's accepted the call and it's loading, that will create a huge business impact on the solution. So what is throughput and how can we optimize it? So throughput is basically the number of concurrent requests a system can handle within the given time interval. So your pages need to be checked, and if you have worked on LWC pages or something like that, there are very good add-ons that actually give you the response time of your pages, of your classes. So that is a very useful way to measure it. Yeah. So one of the reasons there are governance limits is to make sure that your performance remain better. A lot of time people when usually they come into development, they ask like, why are there governance limits, things like that. It is to make sure the performance remain good. Yeah, and you need to calculate the workload accurately. If you're not calculating the workload accurately, then you won't be able to solve it. So one of the key tools, ways to see it is to just check your SOCL queries, how much time they are consuming. Check your LWC pages, how much time they are taking to get a response back. If there's some sort of sorting or something that can be done on client side, or validation, are you doing that on client side or you using server side to do that? It will make system performance a little bit slower. So throughput, there are 3 dimensions to consider. The first one is number of transactions your system make in any time, and the number of users who need to access your system, and the overall complexity and transaction of the logic. So in number of transaction your system is doing, so if you have an e-commerce website, if you put something on sale and there are like 100,000 people coming in on your site, will the system crash? Will the system be able to run those processes simultaneously? That's a very good measure to check how your performance of your system is. Number of users, number of transaction, and overall complexity. So if you've done a lot of things on page load, the page loads are going to take a lot of time, and this will give a bad impression as well. When you're thinking about performance, don't limit yourself or narrow yourself into CPU performance only. So there are sometimes you see CPU limit exceed or errors like that. So it's very important that you don't narrow yourself in that direction only, but keep a bird eye view so that you see all those mentioned cases and characteristics. To optimize your throughput, there are some ways that I've mentioned. The first one is asynchronous processing. So a lot of times, a lot of things that you are using in maybe in synchronous process, and anything that you can throw into asynchronous process, it will save you some time, because at that currently that record is locked, right? So no other process cannot access that record. So if you want to avoid those type of problems, then using asynchronous is a very good out of the box solution. It can help you in removing bottlenecks. Second one is use bulkifications. What I've personally seen is a lot of people use a lot of flows, but they are like hardly any bulkified. So whenever you test it on 10,000 records, it crashes. So make sure that whatever you're writing a flow or a trigger, it is bulkified enough so that you can perform multiple operations at once. Use SOCL. Yeah, the most of the time that I've seen is the SOCL is the culprit, which is taking most of the time. So I didn't know, but in Dev Console, I think there was a very good tool to measure SOCL time. I think it was query optimizer in the dev console, I think. So that is also one of the tool which basically returns you how much time did a query took to run it. So use Social so that you are not overdoing in the limits. Use the platform cache so you are not loading the page again and again, and on every page load you are doing a request to the server and consuming a lot of time and performance. Second thing is latency. Latency, as I said, is how fast a system completes or executes a task. So latency is basically when you are so optimizing the throughput of your system will contribute to improving latency. This is like comes in hand to hand. Another dimension of latency is perceived performance. I think we have already talked about this, that if a user perceives your system is slow, then it becomes an issue. So we need to make sure that we are fighting that perceived perception as well. And perceived performance can be difficult to diagnose because you cannot reproduce it. So it can be slow for me, but it cannot be slow for you, because depending on like what browser I am using, if you are using different browsers and things like that. And it can be a combination of a lot of small issues. So that is also a factor. To reduce latency and improve responsiveness, we should consider these 3, 4, 5 points that I've made. Optimize your reports, because what I've seen is a lot of reports taking filters such as contains and a lot of other strings in the report, big strings, which basically takes a lot of time. This is I think the most common scenario that come when performance is evaluated, that reports are taking long time to generate result. Optimize the filters, so make sure that you are not using contains and long string in that and things like that, but it is specific. Avoid using formula fields, so like a lot of big formulas. So every time a report runs, it basically evaluates the formula and then bring the results, so making it more slower. And simplify your sharing model. This is also very key. So every time a user is made, it does a lot of calculations on Salesforce end. So try to minimize it so that you don't consume a lot of energy, time, and performance in it. Optimize UI components. As I said, use LWC. It is better for performance. It gives you instant responses, and it doesn't have to make all page load. It can give you components that you can run. Use Lightning Data Service. As mentioned, it will give you FLS and all those things that you don't need to do again. And if something can be done on client side, use that. So it will basically you don't need to make unnecessary request to the server. For throughput, what are patterns? What are anti-patterns? Bulkification of your code, DML methods, selective SOCL statements using SOCL, asynchronous processing, platform cache. And in your design standards for anti-patterns for throughput, you are using DML statement within loops. You are using DML statements which are not bulkified. SOCL appearing in loops, synchronous processing, taking record for too long, and Visualforce view state for application. I've seen that as well. So you need to avoid that. For latency, I think it's basically mostly reports that we need to optimize, custom UI components, and sorting on client side if that can be done. The anti-patterns are everything making a request to server, complex sharing modding, filters containing complex formulas, things like that. So the last point is scalability. I'll quickly cover this topic. So scalability is, as I said, the reliability doesn't stay constant. It evaluates with time. So scalability is also something that over time, you can go into. So you need to make sure that your solution is scalable enough that if it is working on 10 records, it will also work on 10,000 record and 10 million records. How can we do it? Basically, data model plays a very big part in it. So if you are making data model with the appropriate thinking in mind, you will be able to solve. You have a better time. I've seen systems where like they have created an object for phone numbers, an object for addresses, and which could have been fields, right? So that can set you anywhere. It can make it better for you if you have optimized it, and if you don't optimize it, it can make your time miserable. Use pre-built Salesforce model. So I've seen someone using order object over Salesforce or order object. So 2 order object just because they wanted some customizations. So use Salesforce suggested objects. Choose right data types because then changing data types will take a lot of time. And choose right relationship. So if it doesn't require master detail, you don't need to necessarily create that. If you can avoid junction, you should do that. Denormalize for scale, but denormalize does not mean change everything into a new table. Make it as optimized as possible. Data volumes. Because the data will increase. If you have hundreds of GBs of data in your system, it is large data volume. So on large data volume, you need to make sure that you are basically so to improve scalability in the org with large data volume, consider these following scenarios like distribute child records. You shouldn't have one user with like 2 million records under his ownership. Ownership of the records. Reduced amount of record data in Salesforce. Data archiving and purging, it is really important because this really optimizes your performance. If you are not using it, if you haven't used those records for like 2 years, 3 years, and there's a possible way you can archive them, you should use on archiving them. It will help overall as well, but in your reports as well. Data aggregation and data tiering. All of these help in batch epics and day-to-day work. So yeah, that's it from my side. Any questions? Thank you. No? So I'll end.
No questions, but appreciation.
Okay.
Honestly, it never crossed my mind.
Okay.
One of the technical architect's responsibilities should be allocating failure. I perhaps due to my beginnings, but I always draw the line within Salesforce. If the error happens in Salesforce, I should, and it's not my responsibility. I'll do my best.
Yeah.
Make it available once in a while.
Yeah.
But when the failure happens, it's not my job to find outside Salesforce solutions for that failure as a roundabout.
Yeah. So I think the best learning experience for me personally was when I was working for health insurance, and the lives of patient depends on that. So if a doctor is unable to sign the DocuSign, and if it failed for any reason, then the prescription user cannot buy it, right? So you need to have like 2-3 multiple steps there, strategies there. If one failed, you need to plug in the other one, or some other way where manually he can do it, right? So all these things I also get to know like very recently when I worked on large scale projects. So yeah, absolutely.
Question regarding performance per se. Say we're sending from LWC a stringified JSON to Apex, and which would be more performant to cast that JSON into a wrapper class, or just cast it into an object, a string object, and then you get variables?
I think the first thing will be to check if you really need to send the string or not, right? So you start thinking from the top. Is there a way we can do it on the client side? No? Okay. Then if we need to send it, are we sending data which we need to send it, or are we just sending everything in it? Right? And what I've seen is like when developers get comfortable with one method, they usually follow that method for everything. So I have a friend, he developed very good wrapper classes, so he used to make wrapper classes for everything. But you need to make sure what your need is basically.
Very nice. Thank you.
Thank you. Okay, thank you.